Hello everybody, Assalamualaikum warahmatullahi wabarakatuh. In this section, I will share to you about my material today. It's about my poster final project and the title is V2V Communication Based Pseudonym Using Asymmetric Cryptography. In this final project, I have two amazing advisors. The first is Mr. Amang PhD and the second is Mr. Amran. Let's start with my background. The accident in Indonesia is increased every year. So one of the solutions for this case is V2V communication that requires communication between vehicles. There are a number of issues in privacy and data security, and this communication requires data to be collected and for who data is used. Some vehicles oppose and get the false information from other vehicles because the lack of privacy. Okay, next is research design. In this picture, we know that registrator give the vehicle pseudonym identity by authenticate the vehicle by its PID, vehicle identity. When each vehicle want to exchange information, information is being encrypted with asymmetric cryptography, which is every vehicle have two key pair. The first is public key and the second is secret key. Before information exchange, the information must be encrypted with asymmetric cryptography and then become the ciphertext. When vehicle 2 already get the ciphertext, vehicle 1 is verify the pseudonym and do the description. We move in the left side. Left side there is a block diagram. There are three steps in my final project. The first is key generation, RSA encryption, and RSA description. The first is RSA key generation. From key generation, we generate two key pair, one for Alice and the other is for Paul. And in the right side is the result. They are alphanumeric random number. And in the bottom of that, there is the step in encryption and description. After the key generated, next step is test the encryption from the user. First, Alice write plaintext and successfully become the ciphertext, and Bob do the description, and the result is also successfully come back become the plaintext. And the next table is the result of encryption description process. The result is 2 byte plaintext become 343 byte ciphertext with 2.02 second and decrypted in 0.077 second. And then 4 byte plaintext become 342 byte ciphertext with 0.020 second and decrypted in 0.05 second. And then last, in 181 byte plaintext become 684 ciphertext with 0.01 second and it decrypted in 0.3 second. Okay, now we move to the result. From 10 times generate K, the longest time took 2.6 second and the shortest time took 1.6 second and the average is 2.2 second. And the next table is the result of encryption description process. The result is 2 byte plaintext become 343 byte ciphertext with 2.02 second and decrypted in 0.077 second. And then 4 byte plaintext become 342 byte ciphertext with 0.020 second and decrypted in 0.05 second. And then last, in 181 byte plaintext become 684 ciphertext with 0.01 second and it decrypted in 0.3 second. Last, we have conclusion. From several tests, we can conclude that the first, average execution time for generating RSA key with the level security of 124 bit is 2.2 seconds. The next is total execution time starting from key generation, encryption, and description on 2 bytes of plaintext is 2.5 seconds. And the total execution time starting from key generation, encryption, and description on 8 byte plaintext is 2.5 seconds, and the last total execution time starting from key generation, encryption, and description is 181 bytes of plain text is 2.9 seconds. I guess that's enough from me. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh. Stay safe everybody.